Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we learn about AWS services. Today, we are going to talk how you can build enterprise level scalable Python-based ETL job using AWS Glue on Ray. Now, AWS Glue on Ray is a new feature provided by AWS. It provides a new execution engine for Glue, and it brings a lot of difference when you try to build an ETL job which is Python script based. But how Ray is different and what difference it makes? In order to understand that, you need to understand some of the fundamentals. So let's go through some of those fundamentals, and then I'll come back how Ray makes difference over there. So let's go to those fundamentals. So first one is that when you're trying to create a Glue job, there are two types of job you can create. You can create a Spark job. Basically, you create a PySpark based job which uses Apache Spark execution engine to do processing of a large amount of data for ETL purposes. You can also use Python shell for the scripting purposes or ETL job purposes. Now, people who are more used to Python-based programming or who use Python libraries like Pandas, NumPy, or AWS Wrangler, they prefer to write their jobs using Python shell. So that's one fundamental I want to keep in mind, that there are two types of jobs you can create, Spark-based and Python shell-based. Now, the second fundamental is Glue supports distributed computing. What does it mean? So when you create a Glue job, you have a choice to select a worker type, and then you can select multiple number of workers. And depending on how many workers you have selected, those many, you can say, execution instances are created. And then in each of these workers, multiple tasks are created. And each of these tasks are responsible for processing a part of your data which you want to process in your ETL job. So basically, you can see here, Glue supports distributed computing engine because your data is processed across multiple workers and multiple tasks in a parallel fashion, which brings a lot of scalability as well as faster processing of the data. So second fundamental to keep in mind, Glue supports distributed computing. Now comes the trouble part, and where I will start moving into why Ray. So both Spark and Python shell can be used for Glue jobs, but Python shell cannot use distributed computing. So when you can see that in the configuration. So for instance, if you create a Spark based job, you will see a configuration like this. You can select your worker type and you can select number of workers. That means here you're saying that I want to use 10 workers in parallel to do parallel processing or computing of your data. So Spark is supporting distributed computing. But if you try to create a Python shell job, you cannot select number of workers. All you select is a data processing unit or capacity for which you want to use to process the data. That means your Python shell is not using parallel computing. It's not using distributed computing. It is running under a single thread. And that is a challenge, because if your data is not processed parallelly, and it is processed using a single execution point, then you will have challenges in processing large amount of data. Whether you are not able to process at all because your compute power is not sufficient, or you process the data but processing take a longer time to finish because you're not doing parallel processing. So the challenge is that Python shell based job, if you create inside Glue, they cannot leverage the distributed computing which is provided by Glue. So here comes Ray. Ray precisely solves this problem. So before Ray, If you have been creating a Python shell-based job, then you are running a single threaded, a single execution point-based glue job. Now with Ray, you can create a Python script with based job, and that job can also do parallel execution of your data processing. That means the bottleneck which you had with Python shell, where it was not able to do parallel processing, that bottleneck is gone when you use Ray AWS Glue on Ray for running your Python script or shell-based job. So what exactly is AWS Glue on Ray? Let's talk about it. So basically it is a new execution engine or new kernel which has been added to Glue. So now in Glue, you can run your job on Spark. You can still run your job on Python shell, probably for a small amount of data processing or so. And you can also run your job on Glue on Ray. So Ray is a third execution option or processing engine which has been added to the Glue. Now what exactly is Ray? So first of all, Ray is an open source distributed computing framework. So Ray is an open source framework which Glue is using as the execution engine for all for Python shell based jobs. Python script based job. Of course, you can use Python script for development. So from your development point of view, it's your Glue job will remain the same whether you're writing the Python shell or Python or into the Ray. So you can use your Python libraries, everything to build your job. It supports computation in parallel, so it supports distributed computing. It uses Glue version 4.0 or above only. So 4.0 is the latest at present. So it uses Glue version 4.0. It cannot work with any of the previous version. Currently, it is under preview. So this execution engine is available in some of the regions. For instance, it is available in Ireland, and I'm using Ireland today for the demo purpose. And right now in preview, it is supporting only one worker type. So you can select multiple workers. As you can see on the screen over here, if I'm selecting Ray as a execution engine, then you do have a choice to select number of workers. So you can select more than one worker, and that way you can do parallel computing or distributed computing to to process large amount of data in a very speedy fashion. But right now, under the preview, it only supports worker Z2X type, which comes with 8 vCPU and 64 GB RAM. But I'm sure this is more of a preview things. Once it becomes generally available, AWS should be providing more worker types. So, in summary, AWS Glue on Ray is a new kernel, is a new execution engine added to the Glue. It can be used to create any Python script-based job using any of the Python library. It works with Glue version 4.0 or above only. And most important thing is that it supports parallel computing. That means you can select more than one worker for your Python script-based Glue job to do distributed processing of the data. So, how can you write ETL job when you're writing on the Ray engine or AWS Glue on Ray? So, few things. You can go to AWS console, Glue Studio console. You can write your job over there, or you can also write your or you can, if you have some Python script externally available, like on your laptop or in S3 bucket somewhere, you can also import from there. You can also do interactive sessions with Glue Studio. So I'm going to in fact show you how to start the interactive session, but I'm not going to show that demo in detail. So, but I will show you a Glue job which I write in the console. Then I show you how to start the interactive session. But in interactive session, I will not go very deep because I have another video already which talks about how to do interactive development in Glue Studio. But I will show you that you can create, you have capacity to create interactive Glue job development using Glue Studio with Ray as an engine. At present, Glue Studio does not support drag and drop approach. So, when you're using when you're using Spark engine, you can actually drag and drop your construct to your activities to create your ETL job. That is not available for the Ray at this point of time. And as I mentioned earlier multiple times, you can use Python script and Python libraries to build ETL job with Ray. So, what are the out of box? So when you select, when you go to Glue and select Ray as execution engine or kernel, then what are the out of box packages which are available? So these are the out of box packages available. So you can use AWS Wrangler, very important for me. I use mostly when I'm writing a Python shell based or Python script based my data processing jobs. You also have PyArrow, Pandas, NumPy, and Modin or Dask as some other out of box packages. So these are the packages which are already available as a part of the execution engine. But it does not limit you, because if you want to add additional library, because I'm assuming that you might want to use scikit-learn or some other libraries in your ETL job, and if that is the case, it is possible, and it is similar to how you used to do earlier, like the way you add additional library into your Python shell job or into your Spark job. Ray is not different. What you need to do is that you can put additional parameter called additional Python modules, this parameter into the Glue job, and then you can provide comma separated libraries. So like here you can see in this example, I'm saying let's use scikit-learn library 0.2.21.3 version. Or if you have some custom library which is stored into an S3 bucket, you can zip it, and you can also provide location to that library as well. So keep this in mind that you're not limited to these out-of-box packages only. You can use other packages which can be installed through pip, or you can also have your custom libraries into S3 bucket, and you can put those libraries. You can also load those libraries as a part of your execution engine. You just need to use this additional Python modules parameter, which is similar to how you have been doing with Spark or Python shell-based job so far. Okay, so AWS Glue on Ray actually uses AWS Wrangler a lot, and now AWS Wrangler is called AWS SDK for Pandas. People who generally write Python shell-based job, they use AWS Wrangler a lot. And let's talk about what are sources are supported at present on AWS Glue on Ray for that. So for instance, if you're using AWS SDK for Pandas or AWS Wrangler, then Ray currently supports the connections shown over here. So for instance, you can talk to S3 bucket, both read and write. You can talk to Athena, that means you can talk to Glue catalog, but right now only read is supported, write is not supported or not applicable. I mean, to be yeah, fair, not supported, it's more not applicable because Athena is used for query purposes. Then your lake formation governed tables are also supported, and your time stream data is also database is also supported. So these are 4 different connection types which are supported at present with AWS Glue on Ray with AWS SDK for Pandas. Now, what different formats which are supported at this point of time? They are Parquet, CSV, JSON, and XSLX, which pretty much covers most of the industry standard people use today, okay, in normal day-to-day data processing. So that's pretty much about Ray. So let's talk about, let's see a demo. Like all my presentations go through a demo. So I'm going to create a Glue job, which is Ray kernel based, and I'm simply going to talk to a Glue catalog, read data from there, and write to an S3 bucket. Okay, so let's build a Python based job in Ray kernel. So here we are in AWS console. So here I have my Dojo my data S3 bucket, where I have put some sample data. I have some sales data, some dogs breed data. I'm going to use my sales data over here as a source data. And then I created an output folder where I want to write my output data. And right now this output folder is empty. Then I go to my Glue console where I have cataloged both sales data and dog breeds data. You can see here they are cataloged both into Dojo database, and you can see the location which point to the S3 bucket location I just showed you. Now it is time to create a Glue Studio job. So I'm creating a Glue job using Ray. So you can see now there's another option where I can use a Ray script editor. So if I select this particular option over here, then I do have a choice to either write a new script, or I want to simply import a script. In this case, I want to write a new script, so I choose this option and then say I want to create it. So now it will create a job which is Ray engine based. So here is my boilerplate code, which is right now nothing, just importing the Ray library. So what I will do, I will simply copy paste some script which I have created. So what I'm going to do here is that here is my script. Oops, come on. Here is my script. So you can see here in the script, I'm importing data AWS Wrangler library. I'm importing Panda as a library. Then I'm simply using Athena to say select star from sales. This is the query I want to run on Dojo database, which I showed you earlier. And then I fill that data into sales DF data frame. Then I created a output location which is output folder in my Dojo my data, and this is my output file name. So on this sales data frame, I put a very small transformation. So out of all the like if you go over here, if I open this one, I'll show you. It has got a lot of columns, but I'm not interested in all. I just want order number, order date, and deal size. So I'm simply filtering on these three columns. And then I'm populating that into a data frame. And then I'm simply writing that data frame to this path over here, and in CSV format. So pretty straightforward and simple code, but everything is Python based. So now I need to configure and run this job. So similar to this, you can write any kind of Python script or Python job. Now, if I go to my job details, I can write my job name over here. I can say this is my Dojo Ray job. Which IAM role, is pretty straightforward in this case. I know which role to use. That's why straightforward for me. Then you can see here you see difference. Now I'm not using Spark, but I'm using Ray. So I'm saying it's a Ray based job. Okay. So the kernel or the execution engine is Ray. It uses Glue 4.0, Python 3. And right now only one worker type jet.2x is available, but that's because it's under the preview. I'm sure more worker types will be available once it is generally available. And here is the magic configuration. You can now configure multiple workers. That means you can do parallel processing of the data. Okay, which I kept it to 3 for now. So let's keep it 3. And number of retries, I like to make it 0 so that I don't end up running this job 3 times if it fails. So pretty much I am ready. So my script is ready. My job details are ready, which primarily that is Ray engine selected and number of workers is 3. And then I save the job. So now I am save the job. Now I can run the job. So if I started the job by clicking on the run tab button over here. Now if I go to my runs, you can see my job is running. So we'll wait for it to finish. So while it is finishing up, what we can do something in parallel which can save some time. So if I go to my job, let me show how you can create a Jupyter notebook based job. So if I go, so if you select this option, which is used for doing interactive development of Glue job, you select that option, and then you say I want to create a new notebook from the scratch. Let's create it. Then it will ask what is the job name, and let's say this is my Ray job. Oops, Ray job 2. Let's keep my execution engine, my row to same, and then here I can select Ray as another engine. So I can select Ray and then say start the notebook. Now it is going to start a notebook which I can use for interactive development of Ray based Glue job in Glue Studio. So I'm not going to show any further development over here because I told you that I already created a video which talks about how to use interactive interface in Glue Studio to do interactive development of the Glue job. Okay, so I will ask you to go and watch that video, and then we understand how to do development. But you can see here now you are good to go. If you want, you can simply like import more libraries over here like that, and then you can start building your job. Okay, so let's go back to my jobs and see if my job is finished. So let's keep the notebook there for now, and here I go. If I refresh it, I should will see my Dojo Ray job, and if I go to my runs, it is still running. So let's wait till this job finishes, then I will show you the output. Okay, so the job has finished. You can see it has succeeded. So now what I can do is that I can go to my S3 bucket, and if I refresh this folder over here, this output folder over here, it should show me a file. Yeah, here I go. I get my sales output.csv file. I can select that. I want to show you the content. So if I come over here query with S3 select, and say this is a CSV format, comma separated, compression is none, output in CSV format. Fair enough. Let's run the query. So I want to just fetch 5 records, not more than that. And if I run that, oops, come on. If I run that, you can see here only 5 rows are fetched, which is order number, order date, and deal size. So my job has actually worked. So this was an example how you can use AWS Glue Ray engine to create a job using Python script. And when you use a Ray engine, then actually it provides, it helps you build enterprise level, scalable, Python script-based Glue job, because Ray engine allows these jobs to be able to do parallel computing and can leverage distributed computing mechanism. Okay, so that makes job more scalable and able to process large amount of data and able to finish job faster than what you were doing earlier with Python shell single-threaded job execution. So that was all about AWS Glue on Ray. Yeah, I hope you liked the video, and if you like the video, please click on the like button. Please subscribe to my channel. I promise to come back again in a week's time with another such video. In the meantime, please stay safe and have a nice day. Bye bye.